Solving a linear inequality follows almost the exact same rules as solving a linear equation. Our goal is still to isolate the variable by using inverse operations. If you add or subtract a number from one side, you do the same to the other. If you multiply or divide by a positive number, the inequality sign stays exactly as it is. Today we're going to learn how to solve linear inequalities, how to graph them on a number line, and how to write the solution in interval notation. Let us start with a simple example. Take the inequality x plus 3 is less than 7. We subtract 3 from both sides and we get x is less than 4. To graph this, we draw an open circle at 4 because the inequality uses less than, meaning 4 is not included in the solution. We then shade everything to the left because x is less than 4. The reason we shade to the left is because all the numbers smaller than 4 makes this inequality true. In interval notation, this is written as open parentheses. Inside we have negative infinity, 4 and a close parentheses. We use a parenthesis on both sides because 4 is not included and infinity can never be reached. Let us do one more. Take the inequality x minus 6 is greater than or equal to 2. We add 6 to both sides, then we get x is greater than or equal to 8. To graph this, we draw a closed circle at 8 because the inequality uses greater than or equal to, meaning 8 is included in the solution. We then shade everything to the right because x is greater than or equal to 8. In interval notation, this is written as an open bracket, 8 with infinity closed with a parenthesis. We use a bracket on 8 because it is included in the solution, and a parenthesis on infinity because infinity can never be reached. You might have noticed that these two examples felt very similar to solving a linear equation. That is because they are. As long as we are only adding or subtracting, the process is identical. However, there is one rule that makes inequalities a little different. If you multiply or divide both sides of an equality by a negative number, you must flip the inequality sign. To understand why, take the inequality 4 is greater than 1. Now if we divide both sides by negative 1, we get negative 4 and negative 1. On a number line, negative 4 is actually smaller than negative 1, which means the relationship has flipped. To keep the statement true, we must flip the sign, giving us negative 4 is less than negative 1. When you divide or multiply by a negative number, the direction of the inequality sign must change. Now let us do 3 examples that bring everything together. Take the inequality 5 plus 7 is greater than 3. We add 5 and 7 together and get 12 is greater than 3. This is simply true, but notice something important. There is no variable here. In the previous examples, we were solving for x. Here there is nothing to solve for. The number 12 is already a fixed point. It does not represent a range of values. It is just one specific number, so there is nothing to graph on a number line because we are not looking for a set of values that satisfy anything. Now for interval notation. Interval notation describes a range of values that make a statement true, not the numbers in the inequality itself. Because 12 is always greater than 3, we cannot shade a range of values on a number line because we are not solving for possible numbers that make the statement true. There is no solution set to put in interval notation. The second example is a multi-step example that focuses on multiplication. Take the inequality 2x plus 5 is less than or equal to 11. First, we subtract 5 from both sides to get 2x is less than or equal to 6. The sign stays the same here because we only subtracted. Next, we divide both sides by 2. Since 2 is a positive number, the sign stays the same and we get x is less than or equal to 3. To graph this, we draw a closed circle on 3 because 3 is included in the solution. We shade everything to the left because x is less than or equal to 3. In interval notation, this is written as an open parenthesis, negative infinity, and 3 closed bracket. The third example is a multi-step example that involves the flip rule. Take the inequality negative 3x plus 4 is less than 10. First, we subtract 4 from both sides to get negative 3x is less than 6. The sign stays the same here because we only subtracted. Next, we divide both sides by negative 3. Because we divide by a negative number, we must flip the less than sign to greater than. This gives us x is greater than negative 2. To graph this, we draw an open circle at negative 2 because negative 2 is not included in the solution. We shade everything to the right because x is greater than negative 2. In interval notation, this is written as an open parenthesis. Inside we have negative 2 infinity with a closed parentheses. Solving linear inequalities is very similar to solving linear equations. The only real difference is the flip rule. Whenever you multiply or divide by a negative number, the inequality sign changes direction. Now that you know how to solve, graph, and write inequalities in interval notation, you have everything you need to work with them confidently. Thank you for watching.